Hello, my name is Amos Tarfa, Amos the math guy. And in this video, I'm going to be guiding you through the concepts from equations all the way to the most advanced topics in Algebra 1. My goal is to give you the foundation to flourish in mathematics. So let's begin with equations. You could grab a notebook, take notes as you learn. So let's dive into equations. One-step equations. So with one-step equations, one of the main things to keep in mind is that you are trying to just do one thing. Whatever the sign you see, you want to do the opposite of that sign. So you have x minus 7 is equal to 12. So you know you need to add 7. But if you add 7 to get rid of this negative 7 on the left, you have to do the same thing on the right side. So that's how we get x plus x on the left side, and then 12 plus 7 would be 19 on the right side. That is how we solve one-step equations. And this gives us the beginning of the discussion on Algebra 1. It is important to note that in order to do Algebra 1 concepts well, you need to have a solid base in pre-algebra. We have a free assessment you can take in pre-algebra to help you find any gaps you have. So reach out to us at countingthecalculusandbeyond.com to get access to that assessment. The key topics before equations would be order of operations, properties of algebra, where you deal with the distributive property, integers and fractions, arithmetic around integers and fractions, negative and positive numbers, and then fractions. If you have a solid base in those topics, you'll be able to tackle equations well. Let's dive into two-step equations. Two-step equations. Now we know there's going to be two steps involved. And so in this case, we're going to be adding 5 to get rid of that 5, negative 5 on the left, and then we add it to both sides. So then 2x is equal to 16. Here's something that is interesting though. PEMDAS is how you've learned to deal with evaluating expressions. When you're solving equations, you actually do SADMAP, we call it, the opposite. So that is something to keep in mind for dealing with two-step equations and multi-step equations. We've moved that 5 over to the right side. 2x is equal to 16. We're trying to solve for x, so we need to get rid of that 2. Well, the best way to do that is to divide both sides by 2, because that's the way we get rid of that 2 on the left side. But whatever we do to the left, we have to do to the right. The division property of equality, we call it. Please note that there are properties of real numbers at the end of your workbook if you're using the Counter to Calculus Algebra workbook, or you can just find them online. And we have them in our free resource called Tools for Mastery in Mathematics. Just feel free to reach out to us if you want us to send it to you. The solution for this is 8. You can plug 8 back in and you'll find out that it works. General linear equations. Okay, well now remember when I mentioned distributive property? That's going to be very helpful right now. You can distribute that 3 in and you get 3x minus 6 is equal to 15. That is because, again, the number on the outside, I think of it like it's going to shake hands with everything on the inside. So 3x minus 6 is equal to 15. Well, now it's pretty much a two-step equation problem, right? So it started as a certain kind of problem, and now it's a two-step equation problem. So what do? We add 6 to both sides. We divide by 3. The solution is 7. Solving with fractions. This is where a lot of students, some students begin to struggle with dealing with equations because they're doing two things now. They're not just dealing with equations, they're dealing with fractions. And fractions are not necessarily everybody's friend. Some people love them, but a lot of people don't. We need to change that. And one thing we need to remind people is understanding prime numbers and prime factorization will go a long way to help you really master fractions. So that's my recommendation. Master prime factorization because it'll help you find the lowest common denominator, and that's a key aspect of this. So if you have a problem like this, x over 3 minus 2 is equal to 1, you can basically think of it as, in one sense, look at that negative 2, right? You should be looking at a negative 2 and thinking, how do I get rid of that negative 2? Oh, I can add it to both sides. Great. Then what do I do to get that 3 on the denominator to come to the top? Well, if you multiply the left side by 3 and that 3 in the denominator will go away, or will become 1, but you have to do the same thing to the right side. And therefore, 3 times 3 is 9. The solution to this is 9. You could check your work. 9 divided by 3 minus 2 is 1. Formulas. When you learn how to work with equations, we start giving you these formulas that you can use to, like you can find different value, you can solve for different variables for different purposes, such as if you have the area as equal to base times height over 2, and you're trying to solve for h, well, we need to get rid of that 2 in the denominator. What do we do to both sides? Multiply both sides by 2. Now we have 2a is equal to b times h. Guess what? We can actually divide both sides by b. So that's how we solve for h. There's going to be more practice problems and examples for you, but this is just a good start of an example of solving for the height if you know the base and the area of a shape. Absolute value equations. In absolute value equations, this is another kind of equation, x minus 5, absolute value is equal to 3. You have to write out two versions, the positive and the negative. And so you get x minus 5 is equal to 3, and x minus 5 is equal to negative 3. So that's a key step for solving the two problems. You set it up as two cases. Now you just solve each one of them as one-step equations. You get x is equal to 8, or x is equal to 2. And those are the solutions for this particular absolute value equation. Variation. This is where equations are beginning to get into the realm of applications in science, especially in mathematics. And so what happens here is that we have direct variation and inverse variation. So if y varies directly as x, so if y is 12 when x is 4, find y when x is equal to 5. Well, with variation, you have to set it up first as we say y is equal to y varies directly as x. So when you do that, then you have to write it as y is equal to k times x. So that's your way of setting up the equation. And now you use the values here, the y and the x, and that gives you a value for k, which is 3. Then over here, they said x was equal to 5, and they want you to find y. Well, guess what? You go back to your formula here. K was 3, x is 5, y would be 15. So we found k, and we're able to solve for y as 15. So that's how we worked this out, but we initially had to set it up as a direct variation problem. Okay, now we're going to do number application. The sum of twice a number and 4 is 14. We have to translate that into an equation. The sum of twice a number, so the number is x, so twice that number. The sum of twice a number and 4 is 14. We just solve it now as an equation that has been set up for x. Age application. I will say that age applications sometimes make me like, why do we do this to people, right? Because it's like, how often do people walk up to you and say, John is 4 times as old as Sue. Some, and the sum of their ages is 20. Find this or that. People don't really do that, but we use these to just help you see the application. So have mercy on the math curriculum writers sometimes, but the examples, I must say, are not as practical because we don't talk like this in real life. But think of it as how can we help you to master the equation solving strategy? So we're trying to use things that might be more relatable to students. So they said John is 4 times as old as Sue. So that means John is 4x and Sue is x. And then sum of their ages, 4x plus x is 20. And now we solve for x. After we get the value for x, we know that Sue is 4 and John would be 4 times 4. Distance problems. This is a key aspect of physics where we deal with distance problems. With these problems, basically what we're doing is we're using distances is equal to rate times time. This is one of the things you're going to learn a lot more in calculus, instantaneous rate of change, discussions around that. But if somebody traveled 150 miles at 50 miles per hour, how do we find the time? Well, we know the formula is distance is equal to rate times time. So then we write down the distance we have, and we write down we know it's the rate, and we're looking for the time. So we divide both sides by 50. That's a practical application. This is actually pretty common, right? We use this in real life. So very good example. Let me know if you have any questions. That's where we're going to stop with the equation section. We'll be back with the next segment, which will focus on graphing. And then we'll get into inequalities, systems of equations, polynomials, rational expressions, radicals, quadratics, and functions. Look forward to learning more mathematics with you. Let me know if you have any questions, thoughts, comments, objections, and have a blessed day.